Right, hello everyone. I wasn't expecting 24 people. I now look like an idiot just sat in my living room eating random crap and having a cup of tea. Right, can you hear me okay? Oh God, it's on your story. That's not what we want. Can everyone hear me all right? Sweet. Okay, so, I feel so offended. Right, the first thing that someone wanted to go through was electrolysis, which is a pig, if I'm honest. Right, so there's a couple of things with electrolysis. First of all, if we, oh God, so the carnage begins. Oh, is it backwards? Is it seriously backwards? Jesus Christ. Right, I can't immediately learn to do backwards stuff. Right. Why would it be backwards? No, is it good? Sweet. Right. On my screen, it's backwards. That's why it's flustered me. Right. So, electrolysis. First thing to realise is the word. We have electro, meaning electricity, and lysis, which means to split. So whenever we're doing electrolysis stuff, we've got to think something's going to be split up with electricity. And what you do is you have an electric circuit going to two electrodes. Okay. Now, in a circuit, it needs to flow through something. So that usually flows through a substance which we call an electrolyte. Okay. Now, this electrolyte business can be two things. It could either be a molten material, or it could be a solution. Either way, it's going to be consisting of ions. You have got two things sticking into that, which we call electrodes. The way to remember this, swanky colour change, boom, is panic, which stands for positive anode. Oh, the pens are everywhere. Negative is cathode. Right. So what happens is the electricity will kind of flow through the circuit, go through this material, and then go around and complete the circuit. Okay. So what actually happens at each electrode? This one here is negative, so this is the cathode, because remember, negative is cathode, and this one over here is anode. Oh, I can't really see. Oh no, disgraceful. Boom. There you go. Lovely. Oh, it's just so amateurish. All right. Let's go even higher. Lovely job. Yeah. So what happens at each point? Now, in the electrolyte, you're going to have positive ions and negative ions. And the key thing here is that they're always going to be attracted to the opposite. Okay, so these negative ions here are going to be attracted to the positive anode, and these positive ions there are going to be attracted to the positive anode. Right, so if we zoom in, what? 10 out of 10 for specs. Okay. At this point, the negative ions which could be something like chlorine, which is now chloride ion. It could be something like fluoride. Okay, and yes, this is chemistry paper one. Enjoy that. Oxide, if you've got like aluminium oxide. Don't worry about electrolysis. Electrolysis is like super hard. I think it's the hardest thing in the whole of GCSE, so don't worry about it. And at the cathode, okay, you have the positive ions, okay? And what's going to happen, okay, is electrolysis is, as we said, is splitting stuff and going back to where they were. So if I've got something like a magnesium ion, which is magnesium 2+, it wants to return back to an atom, right? Now, because it's 2+, the way it can go back is if I gain 2 electrons. Because it's 2+, each electron is a negative, got a negative charge, so they kind of cancel out and back. On the other side, okay, if I had something like a chloride ion, to get back to kind of a chlorine atom, you're going to lose an electron, and that gives us a chlorine. Now this one's actually a little bit more annoying because chlorine doesn't go round just as on its own. It goes round as a diatomic. These are 2 half equations. Okay, don't worry about that. This is definitely higher. Okay, half equations are higher only. But I know the person who asked it is doing higher. In terms of aluminium, which I think is the specific one you're asking about, this is the way that you extract aluminium oxide. Oh God. All right, actually scrap that. Whoa, you're gone. If I am I okay? No, not really. I'm tired, and I don't know what's happening, if I'm honest. I can't believe I have roped myself into doing this live stream business. When we look at metals, okay, we have what's called the series. And at the top, we have some really super reactive metals, things like potassium, things like sodium, things like lithium. We've also got up there magnesium and aluminium. I can't actually remember which way round they go. It doesn't really matter. Okay, those are your super reactive stuff. At the bottom, I'm coming back to that electrolysis thing. Don't worry. At the bottom, you've got super unreactive stuff. So things like gold, silver, platinum, things like copper. Okay, and in the middle, you've got kind of all the other stuff you kind of have heard of. So that would be something like iron. Zinc is actually above iron. Lead, something like that. Okay. Now, I've left these kind of half gaps here for a deliberate reason, because in here we could put carbon, and in here we could put hydrogen. Okay. Now, if I want to extract a metal, this is a little bit more paper too, but the reactivity theory, reactivity series thing is important for displacement reactions. Everything below carbon here, okay, carbon is more reactive than it. So if I do a reaction of that metal kind of compound with carbon, the carbon wins out. So for instance, if I take iron oxide plus, yeah, that way, plus carbon, it's that whole thing where you have the more reactive thing. In my lessons, I've talked about the more attractive boyfriend winning out. So if you look at carbon, carbon is more reactive than iron. So it kind of kicks it out and replaces it. So you end up with carbon. You don't have carbon oxide though, you have carbon dioxide plus iron. And now the iron is on its own and it's extracted. Okay, so to go back to that electrolysis thing, everything above carbon can't be extracted with carbon, so you need to use electrolysis. So the question in point was talking about the electrolysis of aluminium oxide. You don't actually need to know the full apparatus. Okay, the things that you need to know is thinking about the fact that so we're going to need to use electrolysis for this. The main thing is the thing ionic compound, and the only way that ionic substances Liam, you're not even doing the exam. You're year 10. Oh no, we're suffering from serious lag here. Oh my God, the camera's gone. Live stream. You can still hear us. That's good. It's because the camera's gone. Let me try again. Yeah, I know. Yeah, I can. I know you can. You can hear it. Right. So the only way that I managed to get this to work is that I downloaded an app phone into a webcam, and I have it. That app has now decided to be stupid. Right, come on. No, I don't want to. Oh no, this is disgraceful. Oh no, no, not Primrose Kitten. Right. I mean, I love Primrose Kitten. I'm gonna send feedback. YouTube are awful. Right. Let's restart the stream.